For most of human history, cutting a path through solid rock meant risking everything. Before automation, workers spent their lives underground, swinging pickaxes and packing dynamite, constantly surrounded by the very real, lethal threat of sudden cave-ins. Today, our infrastructure demands are completely different. We need to push massive, multi-lane highways directly through unyielding mountain ranges and run high-speed subway networks deep beneath the ocean floor. The core physics problem here isn't just the sheer density of the rock. It's the fact that the exact moment you carve a void into the earth, millions of tons of downward mountain pressure immediately want to crush that empty space. The solution is the Tunnel Boring Machine, or TBM, a colossal, mobile subterranean factory. This front face alone can span several stories, physically dwarfing the engineers standing at its base. This machine operates by simultaneously destroying the rock face in its path and assembling a permanent, reinforced shield directly behind it. Let's break down exactly how this works, starting at the front of the machine where the rotating wheel meets the solid rock face. Despite its name, this massive wheel doesn't actually drill. Instead, it relies on rows of heavy-duty disc cutters, rolling them against the stone under extreme hydraulic pressure. As cutters roll, they force intense pressure waves into the rock. This creates localized microfractures, a failure called spalling. Eventually, these connect, and the solid rock face shatters into large flakes, rather than grinding into dust. By applying pure, calculating brute force, the TBM takes an immovable mountain and turns it into manageable, transportable rubble. Generating rubble is only half the battle. If you don't move it, the machine gets stuck. So we have to look at the chamber immediately behind that spinning cutter head. As new rock flakes break off, they fall through carefully designed gaps in the front wheel. The slow, rotating motion acts like a giant shovel, constantly scooping this loose material upward. The rubble drops into the center of the machine onto a continuous conveyor belt system. This belt runs continuously, carrying the destroyed rock back through the length of the tunnel, sometimes for miles, until it reaches the surface. Because the system never stops moving, it hollows out the earth entirely in real time. It never has to pause just to clean up debris. This brings up an interesting mechanical problem. If you press a massive machine against a rock wall with millions of pounds of force, how do you keep it from simply sliding backward? The answer is at the very rear of the machine. The TBM carries thousands of heavy, precast concrete segments right down into the tunnel with it. The front wheel halts its digging. Inside the outer shell, specialized robotic arms hoist these pieces into place, assembling a perfect, watertight ring. Once the ring is locked, the propulsion cycle begins. Powerful hydraulic jacks deploy from the body of the machine, pushing against that fresh concrete wall to drive the entire front cutter head forward for the next cut. The machine uses its construction to fuel destruction, continuously building a permanent foothold inch by inch. When you pull back from the machine and look at the final product, the efficiency is striking. It leaves behind miles of perfectly sealed, structurally sound tunnel, leaving the earth above entirely undisturbed. This method has physically connected sovereign nations, allowing us to build permanent infrastructure like the Channel Tunnel directly beneath the ocean floor. Modern megacities rely entirely on these hidden networks. High-capacity subways and deep underground aqueducts for fresh water are only possible because we can safely carve out permanent space where none existed. Passing through a modern tunnel means traveling through the wake of a factory that carved and cased several meters of earth every day, miles below the surface. These passages remain as the lasting footprint of an entirely self-contained subterranean construction cycle.